Welcome to EDU World Space.
In this question, we have a very long wire with charge density, linear charge density lambda. Okay, so then there are 2 points that we measure the voltmeter. So I call them point A and B, and then point A is 2.5 cm, and then point B is 3.5 cm. Okay, and then it was given that the potential difference, when you use a voltmeter to measure the potential difference between points A and B, you get 575 volts. Okay, VAB is 575 volts. Okay, and then we want to find lambda in part A, and then in part B, if we move the 2 points 1 cm further, what would be the potential difference? And then in part C, the 2 probes are placed at same distance away from the wire, and then we want to find the potential difference. Okay, so to do part A, okay, so we'll be using the formula in the textbook. Okay, it is being derived that VA minus VB is equal to lambda over 2 pi epsilon naught natural log RB divided by RA. Okay, so one thing we need to take note is that VA is greater than VB, okay, because it's closer to the wire. Okay, so here we note that VA minus VB is 575 volts, and then we have RB equals to 3.5 cm, RA equals to 2.5 cm. Okay, so we can substitute 575 equals to lambda over 2 pi epsilon naught natural log 3.5 divided by 2.5. Okay, so lambda is 575 times 2 pi times epsilon naught, which is 8.85 times 10 to the negative 12, and then divide by natural log of 7 over 5. Okay, you calculate this, you get 9.50 times 10 to the negative 8 coulombs per meter. Okay, or 95 nanocoulomb per meter. Okay, so this is the answer for part A. Okay, next in part B, now we move the probe 1 cm further away from the wire. Okay, we are asked to compare the potential difference, in this case, to the 575 volts before. Okay, so the answer is no. Okay, the potential difference, okay, you will read, okay, the reading on the voltmeter will be less than 575 volts. Okay, so why is that so? Okay, first we state the definition of potential difference. Okay, delta V is negative E dot dr. Okay, so in this case, when the points are further away from the wire, okay, the electric field, the magnitude of the electric field decreases. Okay, yeah, so delta V decreases for the same delta R. Okay, yeah, or you can refer to the formula from previous question, like VA minus VB is lambda over 2 pi epsilon naught natural log RB divided by RA, right? So we can just say delta V is lambda over 2 pi epsilon naught natural log RB divided by RA. Okay, so you can think of it as delta V1 is equal to 575 volts, is proportional to natural log of 3.5 divided by 2.5. Okay, and then delta V2 is proportional to natural log of 4.5 divided by 3.5. Okay, so and then you can compare that ln natural log 7 over 5 is greater than natural log of 9 over 7. Okay, so with that, delta V2 will be delta V1 will be greater than delta V2. So delta V2 will be less than 575 volts. Okay, okay, so this is how you can explain part B. Okay, now we move on to part C. Part C is this situation. So you have this wire and lambda, and then you put two probes at the same distance away from the wire, okay, just that they are 17 cm apart, and then you take the potential difference. Okay, okay, so in this case the delta V equals to 0. Okay, so both probes, okay, are at the same potential. Okay, which is why the potential difference will read 0. Okay, yeah, so that's all for this question.